Hello everyone, and thank you for joining us today in this session on static libraries. So firstly, what is a static library? So a static library is also known as an archive. It's just like a collection of object files that are packaged together into a single file. We all know what object files are. We said there are three stages of compilation, right? We know that we have the pre-processing stage, the compilation stage, the assembling, and then the linking phase. So these object files are generated after the assembling stage, right? Before what? Before the linking phase. So static libraries is a collection of all those object files, right? All those object files, collecting them together and package them into what? A single file. So that's just what a static library is. Okay, so the object file contained in the library are typically compiled version of source code. We know that, right? When we wrote our codes, after compilation, an object file is what is generated. So that object file is like a compiled version of our main code, right? So these static libraries are typically compiled version of this source code. So these object files that are contained in the static library are just like a typically compiled version of our source code. So all we need to do today is to see how we can create our own static libraries. So we've been using the stdio.h, something like this. Let me just open a random file like this. So we've been using this like this, stdio.h, right? So this stdio.h is a header file, and it is also what an example of a static library, or let me say it is contained inside a static library. Okay, so this stdio.h is contained in a static library which is normally called the libc, lib and then c. So this stdio.h is contained within that static library. So we have the stdio.h, we know that we have the string.h, we have a lot of this, we have the we have the maths.h. So all these are what are standard libraries here, right? All these are standard libraries. So collection of all these standard libraries here is what made up the static library. Okay, is what made up the static library. So we all know that just like in this case of stdio.h, whenever we are to use the printf function, the putchar function, we normally import this, right? Why? Because those functions have been written inside this header file, this stdio.h, right? We have their function written here. Okay, so we have to include this for us to be able to do that function. So if you can remember, all we've been doing in the past in these projects, in the previous project, is we are not using the standard library, right? We are trying to create our own libraries. That's why we are using this. If you have not forgotten, we are using what? main.h. So this is our own library also. So today we are going to see how to make this our own library a static library. When it is a static library, it means someone can even use that library in their own code. Okay, someone somewhere can import the library just like we used to import stdio.h. So someone somewhere can import your own library and can use them to write their own code. So that is all what we are going to see how to do today. Okay, so let me close this and let's begin the process. All right, so before that, just to go through this material here and go through what static library is, I've already explained to you in brief. So you can go and check for this AR and this one and this rallib function here. So let's move straight to the task and see how to create our own static libraries. So the first task here says we should create the static library named libmy.a. So this is showing that what this is a static library when you see .a, containing all the functions listed below. So if you can remember, we've been creating our own functions ourselves, right? So as you can see here, this looks like function prototypes, right? These are prototypes of different functions, and I assure you all these prototypes here, we've created them ourselves. Okay, in the previous tasks we've been doing, from the task on functions, more functions, pointers, arrays. So we've been dealing with these functions, we've been writing functions from that time, right? So, and these are some of the prototypes. These are some of the prototypes. They are selected like randomly from these different projects, and then they are given to us here as what? As our own prototype. So we are to create our own static library based on what? These prototypes. So They said what? If you haven't coded all of the above functions, create empty ones with the right prototype. So if you have not created the functions of these different prototypes, you can create an empty function. That means you can just create the function even if it does nothing. Okay, that's just an empty function. It does not do anything. Just create the function. With what? With the same prototype, just like this. That's what they said. So after creating the function with these prototypes, just ensure that you have your functions created with these different prototypes. Okay, let me show you mine here. So you can see these are the different functions. Okay, I kind of coded these functions again, even though we have them. You can just copy them from your existing repo since you've been pushing it to GitHub. Look for the functions and then create the function. So it's because I don't want it to take time, and this is not what we are here to do. So I created these functions again. So let me open my header file for you again to see. So this is the header file. As you can see, it contains everything. It contains all these prototypes here. Okay, all these prototypes here are there. So let's begin creating our own static library. So to do that, let me show you something here. You have to follow this file here. Just open this file here. I've already opened it here. So let's follow that file to create our own static library now. Okay, so what's the first step? As you can see, after listing the content of the directory, it displays all these .c files, including a header file called myfunction.h. Okay, so the next thing is what? The next thing is to compile all these C files, because we cannot create our static libraries without compiling them. We have to compile our C files so that we'll be able to generate our object file. Okay, to create static library, we have to generate object files. So we cannot generate object files without compiling. So I will simply copy this. I'm sure by now you must have known what the function of this command is. So this is just compiling using normal flags, right? And it's compiling all .c files, all.c file. And what does this -c do? I've explained to you this. It says that just compile, but stop after generating the object code. That's just what this flag does. Okay, since we are interested in getting the object code, right? It's when we have the object code that we'll be able to create our own static library. So now let's compile these programs here now. Let's compile them. Yes, so now you can see they have been compiled, right? So the next thing is what? Let's press L here and see, just like how they do. So you can see we have our object files and we have our C files all here, right? Different object files have been generated for this C file. As you can see, we have isopper.o, we have isopper.c, we have memset.c, memset.o. So these different C files have their own object files now. So we are interested in the object files. As you can see here, this is a combination of the C file and the object file. So the next thing is to create the static library. Now we've just compiled the C files. So now it's to create the static library. So to create a static library, we have to use this command AR here. So what does AR does? AR stands for archive. I've already told you that static libraries are also called archives, right? So AR stands for archive. You are telling the compiler that, okay, I'm about to create a static library. Okay, so when you pass this command, this flag -rc, it means that this R is saying if the static library I'm about to create already exists, then replace it with what I'm going to with the current version I'm about to create. Okay, it just replaces an existing static library if it exists. So this C here means create. It means if the static library I'm about to create does not exist, then just create it. So this is just saying that if the static library exists, then replace it. Okay, and the C is saying that if it does not exist, then create it. That's just what this is. So the next thing is to pass the static library name, the name we want to give our static library. So in this case, we are given what? We are told to use this libmy.a, right? So I can simply say libmy.a. So when it sees .a, it knows that yes, this is a static library. So what next again? So since I said we only require to create our static library, we only need our object code. So that's why I will be saying, okay, asterisk.o. We all know what asterisk means. It means a wildcard. So So this is saying that anything that ends with .o, I want to target it. So it's going to create a static library for all the object files, and these object files are what are compiled version of our main code. These object files are created from our C files, don't forget. So these .o files are compiled version of our own program, a program we wrote, right? So this is saying that, okay, all the .o files, I want to merge them and create a static library called libmy.a. That's just what this command is saying. Okay, so let's press enter. So now I think our static library now has been created. Okay, so let's try using this command. Let's say ar -t. This will list some of this thing for us, some of this content of our static libraries. School, right? Sorry, libmy, our own is libmy, right? .a, isn't it? So let's list it. So you can see it has listed, not some, sorry, I said some. It's going to list all of what? All of our .o files that are in our static libraries. So these are the different functions that make up our static library called libmy.a. Okay, as you can see them, this is just .o files. Take note, it is just .o, no .c. Okay, this is a compiled version of our .c file. So you can see .o, all of these are .o. So what's the next thing now? The next thing is to run a command which is called runlib. What does runlib does? Okay, so runlib is just, it allows you to index the content of your static library. Okay, so when you create your static library, the files are they are just mixed up. So when you use runlib, it's like you are creating a table of content, okay, in your static library for the different functions in your static library. Just take the function of runlib as just creating a table of content. It's just that it is indexing, right? It is indexing your static library. Whatever is in your static library, it is being indexed by runlib. So that what? So that whenever you are to use anything from your static library, the linker, which is supposed to get the function, will just what? Know where to go and look for the function directly without taking more time. This reduces the time for the linker to get that particular function and then execute whatever it wants to execute. Just take this as you trying to get a topic in a textbook. Instead of you to be moving randomly page by page looking for it, you can just go to the table of content, right? Just go to the table of content, you look for it and check for the page, and then you open that particular topic, right? So that's similar to what runlib does. Runlib index everything, all the functions in your static library, so that the linker will be able to see those functions without wasting much time. So now we have to index it. So we have to say libmy here .a, right? Sorry, I used apostrophe, sorry, comma, .a. This is our static library. You just run runlib libmy.a. So press enter. No, sorry, that's not the command. It should be, yes, it should be ar this. So you can see it doesn't make any difference. You'll not be able to see the difference here. Actually, indexing this runlib is just to help the linker, okay, to get things very, very quick. Okay, so let's clear this. So now we have what we have indexed. So now let's test our file. Okay, let's test our file here. So let's go back. We are not using this, okay, because this is not our own static library, right? So we are not using this. So let's go back here. We have to scroll down. You can see after pressing ar, let me run the command again. As you can see, we got this, right? So let's try what? Let's go down. Let's try running this command first, nm. Okay, this helps us to list the indexed file. Okay, so nm libmy.a. So you can see these are the files. They are in their indexed format. Okay, so this is what the nm does as well. So let's move now. Let's scroll down. Let's create this main.c file. We are now testing. So I can simply say main.c. Alright, so let's copy this here and let's paste this here. Okay, so now let's save and exit. So what's the next thing for us to do? I think that's all. So the next thing for us is what is to compile like this. So we are going to use this to compile. Let's paste this here. Okay, so you can see it has been compiled. So let's run the file ./quote, right? Quote. So you can see we got what at the end of the day my goal was to be the best hacker. At the end of the day my goal was to be the best hacker, Kevin Mitnick. So we've successfully created our own static library. Okay, we've successfully created our static library and we compiled it, and then we run the compiled file. This is used for testing. Okay, the aim of this this main.c file is to test, and we've seen that and we've seen the result. We've gotten the same result. So that's just what this task is asking you to do. So you can add, commit and push, then run your checker. It will work. So the next thing says we should create a script called what? The script should be called create static lib. It should be called create static lib.sh that create a static library lib all.a from all the .c files that are in the current directory. So this is asking you to create a script. We all know what a script is. So whenever you run that script, the script is expected to create a static library called this from all .c files. Okay, so how is this supposed to work? Let's create the file first. Let me copy this. Copy and paste here. Paste. Oops, I was supposed to say vi this, right? So we are to create a script, right? So I will say hash exclamation right /bin /bash, right? I hope you've not forgotten the syntax. So what next again? So we are told to write a script that create a static library, right? Whenever the script is run, you should create this static library from all.c file. Take note of this. It says all.c, not all.o, right? So it means that before we create our static libraries, we have to compile all our C files, because static libraries are created from what? From .o files. So, and this is saying from all.c file. So we have to compile them to what? To .o files. Hope you got the point, right? So our script should first compile and then create the what? Create the static library. Okay, so to do that, we have to just say gcc here. Then we have to use the flag -c. Don't forget, what does that c do? That -c tells the compiler that, okay, stop immediately after generating the object code, which is .o. Right? After generating the object code, then stop. So it says what now? It says files that are in the current working directory. So since I'm talking about the current working directory, right? Take note of this, that are in the current directory. So the directory I'm currently working on, I'll just simply use this dot to signify the directory. This signifies the directory. // Whenever you see this // you know it's signifying a directory, right? Normally you see / directory here. So this is showing a directory. So this // here is showing us that what is saying that what we are targeting the current directory. You must have been familiar with all these things, right? From shell permissions and all these things, git, right? You must have been familiar with them. So this is saying we are targeting what? The content of the current directory. So what am I targeting the current directory? All.c file, right? So I will simply say *.c. So now this will allow me to what? Target all files ending with .c. So I'm saying, okay, compile all of the files that are in the current directory that ends with what? .c. And don't compile to the linking phase. Don't generate an executable file. Rather, stop immediately after generating the object code, because I'm only interested in the object code to create my static library, right? So now let's add the command to create our own static library. So the command is what? AR. Don't forget, for archive, I will use RC, which tells the compiler that, okay, if the library I'm about to create exists, then replace it. If it doesn't exist, then create another one, right? So what is the library name? We are told to use libol or libol, or what should I even call it, .a. So let's paste here. Then what again? we are still targeting the current working directory, right? We are targeting all the .o files now. So I will say / still targeting my directory, because all .o files are in my current working directory. We know that, right? Because the C files are in my current directory, so the O files has to be what? Also in my working directory. So I will simply say asterisk and then what? And then .o. This will allow me to target all .o files. So this is saying create a static library of the name liball.a. okay, but check for the files .o files that are in the current directory and use them to create that static library. That's just what this is asked from you. Okay, so let's save this and exit. That's all. So if you like, you can convert it to executable. Since it's a script, u+x, and then what's the file name? Create, right? If you like. Yes, so it's fine. All right, so now let's run the file here. This is it, right? So let's try running it ./create lib.sh, right? Okay, so it has now been what? It has been created. So now let's see the file. Let's see the content of that static library. I'll just say ls *.a here. I'm using this same command here. Okay, this same command here. So paste here. So you can see we got what? liball.a. The reason why we are seeing this is because this is the static library we created in the previous task. Don't forget, right? That's why I'm saying libmy.a. So this is now appearing. So this means that after running this script, this /create this thing, create static lib.sh, that's the file name here. After running the script, it means it has created the static library since it is visible here, and that's the function of the script. The function of the script is just as to create a static library. What if I run the script again? What do you think will happen? Let's run the command. It's not going to create another one because we used what? Don't forget, we used the flag -rc. We said if the file already exists, or if the library already exists, just replace it. Okay, so that's why this is getting replaced now. Had it mean we did some update on our static library, so we can just rerun it and it will replace the old version of the library. Okay, so hope you got this, right? So the next thing is what? Is to use this. Let's run this command and see what we will get. This will allow us to list what is inside the static library. Okay, so let's run. So you can see we got 0 is upper, memset. You can see them, right? You can see we have them here. We have them here. So that's just all what this is required from you. Okay, that's just what you are asked to do, nothing else. Okay, so the next thing is for you to just add, commit, and push. So after adding, committing, and pushing, then you can run your checks, and I'm sure it will work. If there is any problem, then we can figure out how to solve this problem. So that's all I have for you for today on static library, and I'm sure there is no more confusion about it. Okay, as far as you read through the materials and understand what it does, all you need to know about the static library is just these three commands here and what they do, and their different flags. That's all. Okay, so thank you for joining me today. We'll meet in our next session.